Now let's have a look at using SOHCAHTOA, or sine, cosine and tangent, to solve problems with right-angled triangles. We've got two similar triangles here. So ABC is similar to PQR. Similar, of course, means that they have the same angles. So they've both got a right angle. They've both got this angle X at the bottom, and they've both got an angle at the top that's also the same. Because they're similar, that means that the sides are all in the same ratio as well. So the ratio of P to R is the same as the ratio of A to C. The ratio of B to A is the same as the ratio of Q to P. The ratio of C to B is the same as the ratio of R to Q, and so on. Now we can name these sides according to their relationship with angle X. So the hypotenuse is always the one opposite the right angle, and the other two sides are the opposite, which is opposite angle X, and the adjacent, which is adjacent to, in other words, next to angle X, but isn't the hypotenuse. So take a moment to work out which is which on these two diagrams. So these two are the hypotenuses, opposite the right angle in each case. And then the opposite is opposite the angle, and the adjacent is the other side, the one that's next to the angle. Now, for a given angle X, the ratio between any pair of these sides is always the same. So as long as this angle stays the same, the ratio of Q to P is going to be the same as the ratio of B to A, and so on. And we give these names. So if we talk about the opposite divided by the hypotenuse, so R to P, or R divided by P, or C divided by A, that's called the sine of the angle, and we write it as sin X. When we talk about the adjacent over the hypotenuse, so Q over P or B over A, we call that the cosine of the angle. And when you've got the opposite and the adjacent, opposite divided by adjacent, so R over Q or C over B, is the tangent of angle X. And a helpful way to remember this is this SOHCAHTOA that I mentioned at the beginning. Sine is opposite over hypotenuse, cos of the angle is adjacent over hypotenuse, and tan of the angle is opposite over adjacent. Some people have mnemonics that they like to use for that. I've heard some old horses can always hear their owners approaching. Selly Oak Hospital can always handle the odd accident. That's one local to me. I'm not sure if Selly Oak Hospital actually still exists, but it worked well when it did. And there's the trig ratios. We call these trigonometric ratios, or trig ratios for short. Sine X, cos X and tan X, just written out as formulae rather than as triangles. And remember, you can only use SOHCAHTOA with a right-angled triangle. If the triangle isn't right-angled, then it's no use to you. Now, let's have a look at how you use SOHCAHTOA to find an unknown side. So you can use sine, cosine and tangent when you're dealing with two sides and one angle. And you know two of those and you want to know what the other one is. So if we know an angle and a side, then we can use that to find the other side lengths. Here's an example. So let's label the sides we're interested in first. P is opposite the angle that we're looking at, and the 5.2 is opposite the right angle, so that's the hypotenuse. So we've got the opposite and the hypotenuse. Since we're dealing with O and H, we need the SO triangle. So we write out the equation. Sine of x is opposite over hypotenuse. In this case, that means sine of 35 degrees is p over 5.2. And then we rearrange it to make the p the subject, because p is what we're trying to work out. So we multiply both sides by 5.2 and we get p is 5.2 times sine 35. And on your calculator, you've got sin, cos and tan buttons. So you just do 5.2 times sin, and then you put the 35 degrees in the brackets. And then press equals, and it gives you 2.98 centimetres. If you find it easier, there's the option of using the cover-up method if you don't want to have to rearrange your formula. So in this case, we're trying to find the opposite side. So we cover up the O in the SOH triangle, and that leaves us with the S and the H on the same level. So we need to do the sine of the angle times the hypotenuse. So P is the sine of the angle times the hypotenuse, which again, of course, gives you 2.98 centimetres because it's the same equation you've got here. Now have a go at this one. Pause for a second and see if you can think it through first yourself, and then press play to carry on. First, you label the sides. We've got Q opposite the right angle. That's the hypotenuse. And then we've got the 6.3. It's not opposite the angle, is it? That would be this one here. So it's the adjacent. We're dealing with adjacent and the hypotenuse. So we need the CA triangle. Cos of x is adjacent over hypotenuse. In this case, that means that cos of 35 is 6.3 over q. Rearrange that, multiply by q, divide by cos 35, and you end up with q is 6.3 divided by cos 35. Again, stick it in your calculator and you get 7.69 centimetres. Doing that one with the cover-up method, we're looking for h, so we cover up the h in the right triangle, and we're left with h equals a divided by c. So the hypotenuse, q, is the adjacent, 6.3, divided by c, the cos of the angle, which of course, again, gives you 7.69 centimetres. Okay, some for you to have a go at. Pause the video and press play when you're ready to go through the solutions. Answers then. For this one, we're dealing with the hypotenuse and the opposite. So we need the SO triangle. The one that we're looking for is the opposite. So sine 72 is opposite over hypotenuse, that's a over 13. Rearrange it and you get a is 13 times sine 72, or if you use the cover-up method, sine 72 times 13 gives you the opposite, which is a. Put it in your calculator and you get 12.4 centimetres. For the blue one, we've got the opposite and the adjacent. We're not interested in the hypotenuse for this one. So if we're dealing with opposite and adjacent, we need the TOA triangle. So tan of 48 is the opposite, which is 5, divided by the adjacent, which is b. We can rearrange that to b equals 5 divided by tan 48. Again, you could have used the cover-up method. We're looking for the adjacent, so we can cover up the a, and we're left with the opposite divided by tan of the angle. Put that in your calculator and you get b equals 4.5 centimetres. For number 3, purple one, we've got the hypotenuse and the adjacent. So it's the CA triangle we need. Cos of the angle is the adjacent, which is C, divided by the hypotenuse, which was 12. Rearrange it to make C the subject, and you get C equals 12 cos 35 degrees. So C is 9.8 meters. And finally, with this one, we've got the hypotenuse and the opposite. So we're dealing with sine, it's the SO triangle. So sine of 65 is the opposite, which is 6, over the hypotenuse, which is D. Rearrange that to make D the subject. D is 6 divided by sine 65 degrees. Put it in your calculator and you get D equals 6.6 meters. Now in the next lesson, we're going to look at how you use sine, cosine and tangent to find an unknown angle.